In this video, we're going to work out the curvature of y equals x squared at the origin. So we're going to work out this curvature right at the origin. Okay, so from our section on parametric equations, we can jump to here. So this thing here can be rewritten as this. So the formula for curvature, which we've already seen, is given by this. So we need to somehow work out the unit tangent vector. So remember, from our position vector, if we differentiate it, that will then give us our velocity vector, which is this thing here. So differentiate this thing here, that will then give us 1. Differentiate this thing here, that will then give us 2t. So from our position vector, differentiate it, it will then give us this. So from our position vector, differentiate it, it will then give us the velocity vector. But we want the unit tangent. So when you differentiate the velocity vector, it will give you this thing here, and this thing here is tangent to the curve. But the thing is, we want the unit tangent. So unit tangent is of magnitude 1. So imagine this thing here, imagine it has a magnitude of 4. So if you get the whole vector divided by 4, it will then give you your unit tangent right here. So we need to divide by its magnitude. So this unit tangent here, we need to get its velocity divided by its magnitude. So to work out the tangent, we need to get its velocity divided by its magnitude. Well, we've got its velocity vector here. We need to divide it by the magnitude of this thing here. Well, the magnitude of this thing here would be u using Pythagoras. 1 squared is 1, this squared is this, and then square root it. That will then give you your magnitude. That will then give you your magnitude. So to get your unit tangent, we need to get the velocity divided by its magnitude. So that will then give us this thing here, because this thing divided by its magnitude would be this thing here, and then this thing divided by its magnitude, 1 plus 4t squared, that will then give you this thing here. So our unit tangent is given by this. So now we've worked out our unit tangent. Now we need to differentiate it with respect to t. So differentiating our unit tangent with respect to t. So if we differentiate this, that will then give us this whole thing here. And then differentiate this, that will then give us this whole thing here. So for this one here, you've got to use a quotient rule. So remember, imagine this as your v, imagine this as your u. So the quotient rule, square the v. So square the v, that will then give you this. Leave the v alone, differentiate the u. So if you differentiate the u, that will then give you 2. Leave the v alone, and then it's blah blah blah. Use the quotient rule, whatever method you want. Differentiate it, it will then give you this. Differentiate this, that will then give you this. So in effect, what we've done is we've differentiated our unit tangent. That will then give us this whole thing here. Well, tidy this up. That will then give you this. And then tidy this whole thing up here. If you think about it, it will actually give you this thing here. Okay, so now we are currently here. So now the curvature is given by this thing multiplying with this thing. But we've got this thing here, we've just worked it out. But the thing is, we want to evaluate it at t equals 0, because remember, we're trying to work out the curvature at t equals 0. So we need to evaluate our dt by d small t evaluated at 0. So we've got to put 0 into here, into here, into here, into here, into here, and so on. So evaluating this thing at t equals 0 would give us well, this thing here evaluated at 0 would be 0, and then this thing here evaluated at 0, this thing here would be 2, and then this thing here would be 0. Think about it, double check, because let's look at this thing here. When you put 0 into here, this is going to be 0, so you've got 1 here. So this thing here would be 1, and then to the power of 3, to the power of negative 3 over 2, you've got to do, let me think. I'm going to imagine a square root, 1 over this, q. Well, think about it. I've lost track, but this whole thing here becomes this thing here. So our curvature is given by this. Okay, and the magnitude we've worked out earlier. The magnitude was this. The magnitude was this. Look, the magnitude was this. So we've worked out the magnitude of v. But then don't forget, we need to evaluate it at 0. So later on, you need to put 0 into the t. Well, the curvature evaluated at t equals 0 would be given by, well, this thing here would be 1. This whole thing here, the magnitude will be, well, there is no in the I direction. So this thing here is like 0 across, 2 up. So the magnitude will be 2. The magnitude of this thing here will be 2. So the curvature is 2. So looking at your y equals x squared, the curvature at the origin is 2. The curvature is 2. But here's the thing. You can fit a circle of radius of 1. If the curvature is this, the radius is 1 over the curvature. I will elaborate more on this, but for the time being, all that you know is that the curvature at the origin is 2. But what I'm saying here is that you can fit a circle radius 1 over the curvature, which is a half. You can fit this circle neatly at the origin, because any curve, let's say at this point here, you can fit a circle neatly into the curve at that point there. If you look at the curvature here, you can fit a circle that just kisses the path. So the point here is that you can always fit a circle inside here neatly. Well, the radius of this thing here is 1 over the curvature. Well, the overall the curvature is given by 2. Okay. But by the way, I will elaborate more on this circle thing another time. Okay.